Here is how distributed systems fail in the real world. Order service receives a customer order. It calls the inventory service to reserve stock. It calls the payment service to charge the card. It calls the notification service to send a confirmation email. All synchronous. All direct HTTP calls. Payment service is slow, taking 3 seconds instead of 80 milliseconds. Order service threads pile up waiting. Now order service is slow too. User-facing latency spikes across the entire application. Payment service goes down completely, order service crashes too. This is called cascading failure. One slow service takes down everything upstream. Messaging breaks this pattern entirely. Order service puts a message in a queue and returns immediately. Payment service picks up the message when it is ready. If payment service is down, the message waits in the queue. Nothing is lost. Order service keeps running. Payment service recovers, processes the queued messages. This is the fundamental value of messaging. Azure Service Bus is Microsoft's enterprise-grade message broker. It has 2 core abstractions, queues and topics. A queue is point-to-point messaging. One sender puts a message in. One receiver picks it up. The message stays in the queue until the receiver explicitly marks it complete. If the receiver crashes mid-processing, the lock expires, the message becomes visible again. Another receiver picks it up. The message is never lost. This is called at least once delivery. Your processing code must be idempotent, safe to run twice. Because under failure conditions, you may process the same message more than once. But here is what makes Service Bus enterprise grade. Message sessions. Group related messages together. All messages in the same session go to the same consumer, in order. Use this for order processing, where order events must be handled in sequence. Now this is where it gets interesting. A queue has one receiver. But what if multiple services all need the same message? Topics solve this with publish subscribe. Order service publishes one message to a topic. 3 subscriptions exist: inventory, payment, notifications. Each subscription gets its own copy. All 3 services process the same order event independently. Add a 4th subscription next month, analytics. You do not change the order service at all. It still publishes to the same topic. Analytics subscription just starts receiving messages. And here is the powerful feature most teams do not use. Subscription filters. Payment service only wants messages where order total is above a certain amount. Add a SQL filter to the subscription. Payment service now only receives the messages it actually needs. Everything else is filtered before the message is delivered. Every messaging system needs an answer to this question. What happens when a message fails to process? The consumer picks it up. Throws an exception. The lock expires. Service Bus redelivers it. Consumer picks it up again. Throws another exception. After 10 attempts, by default, Service Bus gives up. Where does it go? The dead letter queue. The dead letter queue is a separate subqueue attached to every queue and subscription. Failed messages land there. They stay there until you deal with them. They are never silently discarded. Here is the operational pattern that works in production. Monitor the dead letter queue depth in Azure Monitor. If it starts growing, something is systematically broken in your consumer. Alert fires. Engineer investigates. Finds the bug. Fixes it. Resubmits the dead-lettered messages to the main queue. They get processed successfully. No data was lost. Without dead letter queues, failed messages disappear. You never know orders were dropped until a customer calls support. Azure Event Grid is fundamentally different from Service Bus. Service Bus is for messages, commands you want someone to process. Event Grid is for events, notifications that something happened. When a file is uploaded to blob storage, Event Grid fires an event. When a virtual machine is created, Event Grid fires an event. When a container image is pushed to Azure Container Registry, Event Grid fires an event. These are built in. No configuration needed. You simply subscribe to the events you care about. And here is where it gets powerful for automation. An image is pushed to your container registry. Event Grid fires. An Azure function receives the event. The function triggers a CI/CD pipeline to deploy the new image. 0 polling. 0 cron jobs. 0 manual triggers. The entire automation chain fires the instant the event happens. Event Grid guarantees at least once delivery with 24-hour retry. Events are never silently dropped. If your handler is down, Event Grid keeps retrying. This distinction matters more than it sounds. A message is a command. When you put an order into a service bus queue, you expect someone to process it. The payment must be charged. The inventory must be reserved. If nobody processes that message, there is a serious problem. Service Bus guarantees it will be delivered and provides dead letter queues for failures. An event is a notification. When a file is uploaded to blob storage, Event Grid fires an event. Maybe 3 things happen: a thumbnail is generated, a record is created in Cosmos DB, and a notification is sent. Or maybe nothing is subscribed. The file upload still succeeded. The event is informational. The publisher does not care who reacts. Here is the practical rule. If you need guaranteed processing by exactly one consumer, Service Bus queue. If you need to notify multiple systems that something happened, Event Grid. If you need one publisher to reach multiple guaranteed consumers, Service Bus topic. Getting this distinction right saves you from over-engineering. Let me show you how Service Bus and Event Grid work together in a real system. Customer places an order. Order service puts a message in a Service Bus queue. This is a command. It must be processed. Guaranteed delivery. Dead letter on failure. Order processor picks it up. Validates the order. Marks the message complete. Then publishes a single event to Event Grid, order confirmed. Event Grid fans out to 3 handlers simultaneously. Inventory service, reserve the items. Payment service, charge the card. Notification service, send the confirmation email. Each handler is completely independent. If the notification service is down, the order still processes. Email gets retried by Event Grid. Payment and inventory are not affected. Compare this to the synchronous version at the start of this video. One service down used to cascade into full system failure. Now each component fails in isolation. The system degrades gracefully. This is part 25 of the Azure series. Subscribe and keep going. Next up, Azure API Management. Let me bring it all together. Azure Service Bus is your reliable message broker. Use queues for guaranteed point-to-point delivery. Use topics when multiple services all need the same message. Dead letter queues ensure no message is ever silently lost. Azure Event Grid is your event routing backbone. Built-in sources fire events for everything that happens in Azure. Subscribe handlers, functions, logic apps, webhooks to react instantly. No polling. No cron jobs. The distinction: messages are commands, events are notifications. Use Service Bus when processing must happen. Use Event Grid when you want to react to things that already happened. Together they give you a loosely coupled, resilient architecture. Services communicate through messages and events instead of direct calls. One service fails, others keep running. The system degrades gracefully instead of cascading. This is part 25 of the Azure series. Subscribe and keep going.